Alright, let's go ahead and get started with the power rule. So what we start off talking about is the derivative of a constant function. In order to do the derivative of a constant function, you probably need to know what that function looks like. So a constant function is really just a horizontal line. Alright? And then we have to go ahead and recall what the derivative even means. So remember, the derivative is really just talking about the slope of your function. So the slope. So we need to know, what is the slope of a constant function? So what is the slope of that pink line over there? The slope is 0. Okay, so for any real number c, dy dx of c equals 0. So remember, dy dx is literally just the derivative. So this is the derivative. You guys tend to freak out when we give different notations. That is the derivative. Okay? Now we're going to go through and we're going to find the derivative of the following. Now, I will tell you, this seems like a silly exercise because all of these are just numbers. But I want you to practice with the notation of it. So with the notation, you're going to go y prime equals 0. Okay, then you're going to go s prime of t equals 0. That's just the derivative of that function is 0. F prime of x equals 0. Now, I know, because I've seen your guys' quizzes and tests, that as soon as you see pi over 2, that makes you really nervous. So one thing that you have to be careful of is pi over 2 is really just a number. This is a number. So pi over 2 is just a value. It doesn't matter what the value is. It's just a constant function. Okay, like I could say that the height of this one is pi over 2. Who cares? So this one still has a derivative of 0. So y prime equals 0. Okay? Now what we're going to talk about is the single variable rule. It says the derivative of x. So it's usually helpful, again, to know exactly what x looks like. So because x is a single variable, it has a coefficient of 1, and it has nothing added or subtracted to it. It's actually just a line that goes through the origin and has a slope of 1. 1 over 1, because it's 1x. So the derivative of x is 1. Remember, derivative meaning slope. It says think graphically about the line y equals x, which is what I have graphed here. It says find the derivatives of the following. So notice this notation here real quick. D dx. This again just means the derivative. That means the derivative with respect to x. That means doing the derivative of the variable x. So this one is f prime of x equals 1. Again, mostly dealing with notation here. S prime of t equals 1. X prime of t equals 1. Now, one thing that you want to know is that we could actually go through and instead of saying s prime of t or x prime of t, I could say d dt equals 1. That's the derivative with respect to t is 1. Okay? So just know that whatever variable they're using, they can do d, whatever it is. So d dx above, d dt right here. Okay? Now what we're going to talk about is it says the power rule. This is something that you guys are going to really enjoy doing because actually it saves you a lot of work. We will not need to do the limit definition of the derivative anymore because we can just use the power rule. Okay? So it says if n is a rational number, then the function x to the n is differentiable and the derivative is n times x to the n minus 1. So what it means is it says take your exponent, and I'll write it here, x squared. Take your exponent and apply it out front. So that gives us 2. And then you're going to want to, I'm going to keep my x, and then I'm going to subtract 1 from my exponent. So 2x to the 1. So my final answer is that y prime is 2x. Okay? Now doing it again with the next one. We're going to do x to the 4th. Remember, we're going to apply the exponent as the coefficient. So 4x, we're going to subtract 1. So 4x cubed. So f prime of x equals 4x cubed. Okay? Now when we get to something like letter C, we have to always represent these functions as x to a certain number, okay, or the variable to a certain power. So if I look at my radical and I need to change it to a power, it should actually say x to the 1/2. Now I'm going to follow the same exact rules as before. So I'm going to apply 1/2 as my power, or I'm sorry, as my exponent, sorry, coefficient. So 1/2, x remains the same. We subtract 1. Subtract 1, and you get negative 1/2. So this is new. Whenever we have a negative exponent, we have to move it to the denominator. That gives us 1 over 2x to the 1/2. And my final answer for this one, because I was presented with a radical, I'm going to finish my problem by making it a radical. So it'll be y prime equals 1 over 2 root x. That would be my final answer, because I'm always trying to model exactly what they've given me. If they give me a radical, I end in a radical. If they give me a fraction, I end in a fraction. If they give me one piece, I end in one piece. If they're all different separate parts, then I do all different separate parts. Okay? So since we just talked about negative exponents, we should know that this one is actually x to the negative 1. And we're going to follow the same exact pattern. Apply as the coefficient. Leave alone. Oops. Leave the variable. Subtract 1. And then we can't have negative exponents, so we bring it to the bottom. Alright. So now we should be able to do letter E exactly the same. So I'm going to go ahead and do that. No narrative this time. Alright, so we should have gotten negative 2 over x cubed. Now with fraction exponents, absolutely nothing is different, so we're going to write them as x to the 2/3. And we'll still subtract 1 just like we did before, so it's going to go 2/3. Now in this one, when you subtract 1, you're really subtracting 3 over 3. So that gives us negative 1/3. And they gave us fraction exponents, so I'm okay leaving them as fraction exponents, but I can't leave the negative exponent. So y prime equals 2 over 3 x to the 1/3. I personally like it as radicals better, but I always go based on what I'm presented with. Okay? So now it says the general power rule. It says the derivative of the term ax to the n, where a and n are real numbers, is a times n times x to the n minus 1. So really we're doing the exact same thing, but you just happen to have a coefficient in front already. So you're just going to multiply whatever you bring down with whatever is already there. So, for example, this one is going to be y prime. Bring down the 2 to join the 3. 6x to the first power, or y equals 6x. So what I want to make sure that everyone is aware, I'm going to go kind of on a side note here, is what it actually means to be y prime is 6x. So if I say the derivative of, I'm going to scoot this out of the way, if I say the derivative of 3x squared is 6x, what you really have here is it's talking about the slope. It's giving you a general formula to find the slope at any location. So if I say y prime equals 6x, and my function is 3x squared, my function looks like this. Hold on one second, let me, okay, I guess I'm not going to erase, that's fine. Alright, so we have our function. 3x squared is kind of skinny. So what we do is, when it says 6x, so if I start off, I'm going to do y prime of 1, which means just plug in 1 to your derivative. So 6 times 1 is 6. That means at 1, which I don't know, is right here, my derivative, or my tangent line, oh, let me see if I can make this a little better. Alright, let's see if I can draw it. Oh, very nice. Okay, so that looks like it has a slope of 6. So that means up 6 over 1, up 6 over 1, up 6 over 1. Now, if I go through and I ask myself another question, like if I want to know what is the derivative at 0? I would do 6 times 0, which gets me 0, which means I have a flat line or a horizontal line at 0, which is true. If I wanted to know anything else, like let's say I wanted to know, I don't know, y prime of negative 1/2. If I wanted to know that, I would plug that in. So I'd say 6 times negative 1/2 gets me negative 3. So what I would do at negative 1/2, we'll go this one in purple. So negative 1/2 would be right here, let's say, and my slope would look like this. Negative 1 or negative 3, which means down 3 over 1. Not very accurate in my drawing. Let's see if we can fix that. Maybe a little better. Okay? So that would give me a slope of negative 3. Notice that it's changing based on where you're asked about, whereas with a line, your slope is constant. With polynomials, your slope is not constant. I just wanted to make sure we were aware of what we were actually doing here. Okay? Now let's go through and continue. So I'm going to keep doing my general power rule. Alright, so I'm just going to write s prime of t. Alright. Now I'm going to go ahead and pause and do the rest of them, and then I can basically narrate what I'm doing. Alright, so I hope that this helps. So what I did was I went through and I just used your general power rule for all of these. The only time that you have to get a little bit fancy is when you get negative exponents, so just be careful and make sure that you're very cognizant of them. So for example, like in letter E, I had x to the negative 1/2. When I subtract 1 from that, that's subtracting 2 over 2, which gets us negative 3/2. Now, one thing that I made sure to do is to put it back into a radical. Okay, so make sure that you put it as a radical if you've been given a radical as your original. Alright. Now for the sum and difference rules, all it's telling you is that you can actually take the derivative of each part one at a time and then add or subtract them as you please. So really everything is identical to what we've been doing, but we're just going to go through and make sure to actually do the derivative of each part. Okay? So, f prime of x equals 3x squared minus 10x plus 2. Remember, we're just applying the exponents as coefficients and dropping them all down by 1, exponent-wise. Okay? And then we're going to do the same exact thing for the next one. Alright? Now just make sure you know that 2/5 times 5 just gets you 2. because the 5 on the bottom and the 5 on the top. Now the next couple are just kind of a little annoying. So here I go through and I rewrite. So I have x to the 1/3. I have plus 5, x to the 1/2. Alright. So now I'm going to go through and I'm going to do exactly what I've been doing. So 1/3 plus 5/2 x to the negative 1/2. Then I'm going to put them back into radicals and put them on the bottom because they're both negative. Now I don't have to put them back together because they were presented to me separately. So that is one good part. Because making a common denominator there does not sound like a fun time. Alright? Now I'm going to do the same exact thing for the next couple. So what I'm going to do is I'm going to pause the video and I'm going to do D and E and then I'll turn it back on so you can watch me walk through letter F. Alright, so go ahead and check those out. Shouldn't really have too many questions. The only thing that you need to be careful of is when you're dealing with fractions and whole numbers and making sure that you count whole numbers as being on the top of a fraction. Okay? Now when you do letter F, what you can do is you can actually divide each part by x. So if you divide each part by x, everything gets just a little bit simpler. Okay, because what you have is you have f of x equals 8x squared plus 4x minus 3 over x, which is x to the negative 1. Okay? So then I just need to take the derivative. The derivative says f prime of x equals 16x plus 4 plus 3x to the negative 2. Okay? So you have f prime of x equals 16x plus 4 plus 3 over x squared. Now this is one of those times that you're presented with it all as one piece. So I'm going to ask that you put it back as one piece. Okay? So that means everything was over x, they need to be over something still. So this is times x squared on the top and bottom. This one is also times x squared on the top and on the bottom. That gives us f prime of x equals 16x cubed plus 4x squared plus 3 all over x squared. For me, it's all about presentation. If you're going to go through and do the derivative, you might as well make it look exactly like it's supposed to look like. So you should make it look exactly like what it started off as. Okay, so if it starts off as one piece like this one did, all over x, I'm going to make sure that this one is all one piece at the end as well. Okay? Alright, looks like that's all we have for you. Have a great day.